let's try a complicated antiderivative in calculus. So for this video, you need to know these two rules. The power rule for derivatives right here, and that the derivative of sine is cosine. If we have this equation, we're trying to find the indefinite integral. The thing that I notice is that there's a function within a function. Generally, when this happens, you're going to want to do a u sub. So I'm going to take everything within this function, and I'm going to set it equal to u. Now, when you set something to u, your goal is to get everything with the antiderivative set to u as well. So what I'm going to do is I'm going to take the derivative of u. The derivative of u we can find using the power rule that we described before. So what I can do is take this exponent, multiply it by the front, and then subtract 1 from the exponent just like we have down here. This should give me 5x to the fourth. But since I took the derivative of x, I need to show this is with respect to x. Notice I have a dx here and a dx here, which I can relate. So if I divide both sides of this mini equation by 5x to the fourth, that'll get them to cancel, giving me this expression for dx. Now I can take this and plug it in for the dx we have in the original equation. So now I'm with respect to u. But notice something. This x to the fourth is in the numerator, this x to the fourth is in the denominator. They're going to cancel each other, giving me this simpler expression. I can take this 5 in the denominator and bring it outside of the integral since it's a constant number. And notice here I just have the antiderivative of cosine with respect to u. And the antiderivative of cosine is sine. And you always want to add a plus c whenever you do an indefinite integral. The last step is to just take x to the fifth and sub it back in for u. So now I'm going to have 1/5 times the sine of x to the fifth plus c. And that right there is the antiderivative of this function.